All right, I figured why not? We're gonna do an abridged speedrun grocery haul. So got all my meals for the week. I've been really enjoying the lasagnas for dinner after work, but got all these enough for the week. And already had enough spinach. I have to hard boil these eggs. It's easier to do that in the morning than to fry them up, scramble them, whatever. And I already got the spinach and the eggs last time. Stocked up the Coke, almost out of orange juice, so I got another one. Got some chocolate milk. Got 2.5 gallon total of the whole milk variety. Oh crap. I didn't turn on my microphone. Oh well. Got some more garlic. Oops, forgot to turn my mic on. Anywho, got more peanut butter, olive oil to mix in with the apple cider vinegar in the spinach. And I already have enough BS. Oatmeal isn't BS. Got the gummy bears all ready for post-workout. I've been trying to eat more of these cereal bars. I have some of these. These are like a meme, right? Nature Valley Crunchy Oats and Honey Bars. These are a meme, but doing them with the peanut butter is pretty good in my opinion. And then, you know, I've honestly had these Oreos for several months, but that is all I got. And yeah, gonna read 1929 now. So another clip for another weekend update. I'm gonna do some micro soldering now because this is the deal. I've been trying to control the stepper motor using the, I don't know what the overall term is, but there are these pins called like the step pin, direction pin, and those are connected to the GPIO pins on the Raspberry Pi. And that's like, I guess, step mode. But then there's another mode for this driver called UART mode. And so the transmit and receive signals are digital instead of analog, if I'm not mistaken. But the default configuration of how this driver board is shipped, the one that I got, is that UART mode only, like the signal only goes through one pin. So what I was just trying is kind of like what the instructions said for this Python driver software, is to effectively split the transmit and receive signals using like a resistor bridge on the solderless breadboard. And that wasn't working. So when I ordered these drivers, there were two that came in the shipment or whatever. Like when you order it on Amazon, they come in increments of 2. So I'm just gonna do what the manufacturer data sheet says, which is you can solder these 2 pads together on the bottom of the board, and then that'll split the UART signal into the dedicated transmit and receive pins instead of only going through by default the receive pin. So then I won't have to split it. And if it doesn't work on this second driver board, then it's okay. I still have the other one and I can go back and forth and troubleshoot between them. So my iron, I believe, is warmed up, and I'm going to throw a time lapse in of some more soldering. So add the flux first. And actually, I'll show you guys. It's probably very difficult to see. Probably not gonna focus well enough super close up, but okay. It's like right there. Okay, there's like 3 pins here. It's like that little dot that's just to the right of the bottom right corner of like that black chip that's right there. So that black chip that's in the center, that's the actual TMC 2209. So I just did a tiny bit of solder or flux for now. So this is warmed up, I believe. So this should literally only take a second actually, so it's not really going to be much of a time lapse. Let me make sure that I've kind of been having heating problems with this soldering iron lately. Okay. This is real tight in here. I don't want to melt plastic. I also don't want to nick the sketch. I don't want to accidentally nick the driver chip. I think I got it. That was very delicate. protect the tip of my iron here. Okay, so it's kind of like I said, super hard to see, but now there's a tiny bit of solder bridging those pads, and it was super tight in there. I almost like nicked the edge of that driver board. Hopefully it's gonna be okay, and I'm gonna test it out now, wipe it off. We'll see how it goes. Alright, so I've got the old one, or the former one here, and I put the heat sink on. That's the blue metal piece on top. This thing runs pretty cool, I feel like, compared to the last driver I was using, the DRV8825. So I didn't put the heat sink on this time, but here we have it. I've got a few straggler, loose disconnected wires here from when I had the single UART signal going, and I had that resistor in there. So got my configuration all back. We've got the 12 volt motor power, and this is on. I really hope this works, man. All right, so I just have to... This is over the serial port. So, and I don't know why my Linux command history refuses to accept the debug script. So I have to scroll up so I don't type it out because I'm lazy. Okay, here we go. Yeah, nothing. Still not good. So maybe if I try it, I don't know, this is a YOLO move. I'm just gonna try to run the command with sudo this time. Yep, didn't work. Back to the drawing board we go. Alright, so I've been tinkering and I put the board that I have, the 2 pads soldered that I just did, put that on my solderless breadboard because I figure that's on the board itself and then it's on the bottom, so like if it is soldered then I can use the transmit pin. If it's soldered but it's a bad connection, I could still control using just the receive pin. So I can't really tell if it's soldered poorly because it's such a small joint that I feel like it should be okay, and it still is working. I'll now get a valid UART connection when I run this debug script that just checks whether or not the UART connection is okay. And then the demo script is supposed to do like action of the motor, and actually this time, that's why I turned the camera on. It's doing clockwise steps, or at least it did last time, so let's see what happens. Like you can hear these little hisses, right? And it's kind of moving, right? Like it went a little bit. And if I touch it right now, there's like a holding torque, or like I can feel there's a little bit of force. And you can hear that little hiss, right? I'm gonna do it one more time. Those were smaller steps than when I first ran it. I'm going to swap out this soldered pads on the bottom board. I'm going to go back to the first one I was using. I might have to like tweak the demo script so that there's a higher current going to the motor, because that was actually like, I guess all I did that was different is that I added a pull-up resistor from the power on the Raspberry Pi to the UART line. So yeah, keep on tinkering and see if something happens. Alright, taking a break from troubleshooting my electronics. Got some food. Got that pho action. Rare steak, double steak. Did the works on the vegetables. Put the hoisin sauce on. Yeah, boy. It's all about the broth, man. It's all about the broth. This is going to perfectly fill up the Tupperware. Boom. That's what I'm talking about, man. Also got some egg rolls. That's not popcorn. Those are egg rolls, boy. And I kind of have to stand up right here and eat it because otherwise my cat is going to assume that it's cat food, because his cat food is cat food, but also everything that I eat he thinks is cat food. So I'm going to enjoy this. It's nice and warm. It's not super hot, obviously, because I had to drive to the place and drive back, but it's like hot enough that it's cooking up the steak right now. Or, you know, I get rare steak, thin sliced, so it's not like I'm eating straight raw meat, but it's like we got the blood in there. You know what I mean? We're getting all the nutrients, all the vitamins and minerals, and give this a sec to soften the noodles up. And I think I'm gonna play around with So I added a 1K resistor to pull up the receive signal on the UART line. I also didn't mention that I clipped the VREF and diag pins that are underneath the driver board, because those are like basically on the same row as where the enable pin is. So I like clipped them and then I put some electrical tape on the board, the solderless breadboard, because that might be causing some EMI issues. And then I still get this like CRC mismatch error. That's why the next step is going to be swapping out my pull-up resistor that's currently 1,000 ohms and go for 4,700, 4.7K ohms. I don't know, we're gonna see what happens. If anything, it's like almost at the point where I'm like, I don't know, I'm conflicted whether I should get like something besides a Raspberry Pi in order to drive it, whether I should do like a DC motor instead of the stepper motor, but I already have the magnetic encoder on my stepper motor. I don't know, I'm just gonna focus on eating. All right, you guys, this is it. At the end of the day, I can't get UART mode to work, but I had to take the motor off of the stand, and I'm reverting to, I guess, analog, step enable, and direction mode. So I, of course, took advantage of AI code writing to modify the script that I was using for the DRV8825, and it's gonna work now, watch. I'm using my keyboard to move it, but okay, I'm pressing two keys here, P and Q. It's supposed to go clockwise and counterclockwise, but as you can see, well, you can't really see the keys I'm pressing, but it's only going clockwise. So I think there's like a small jerk when it changes directions, like it thinks it's gonna go, I don't know. It's pretty inconsistent. It was just like a, one AI query, get this minimal script so I can see if this works. But this is the current state of my experimental apparatus. And then when I push on this a little bit, I'm kind of losing the sturdiness of the epoxy, but there is like a holding torque on the motor now. Probably because I jammed it up against the coil when this script first worked. That's why I took it off of the retort clamp stand. But I also ordered a new TMC 2209 that's a different brand. This is like Big Tree Tech, and I got an Adafruit, I don't know how to pronounce that, Adafruit one. The Adafruit one has a little bit easier access, like it has like those little, I don't know what they're called, but it's like you unscrew the header and then you can put a pin in and then screw it back in. And then it has like a capacitor on it and stuff for, preventing voltage spikes and all that. So it's like a better regulated board, so you can just more or less plug it in and use it instead of this Big Tree Tech one. But I might take this off or the ruler attachment and reseal the epoxy. I think the bottom ones kind of slip in. Like if I disengage the script now, there's no holding torque. And I'm pretty sure that in my messing with it just now, the epoxy on the bottom collar wore off. But I don't know, this is, I guess, progress for the day. And then the way that the motor is mounted, it's on like a clamp, and then there's this screw here. And I noticed when it would act, the motor would spin. It would kind of like seesaw back and forth, and then this side of the protractor or the ruler attachment would hit the coil. And I think that disrupted the epoxy on here. So I'm gonna take the attachment off, I'm gonna reseal the epoxy, and I'm gonna think of a way to more securely fasten this onto the clamp that's on the mount. Cause it's like, I don't know if I wanna like permanently try to epoxy seal that, cause obviously it's gonna be torquing. It's gonna be shaken back and forth, and obviously the epoxy is not the end all be all. Yeah, like right now I can see that bottom collar is like probably completely removed from this. So I don't know, that's like my weekend update. I also took the magnetic encoder off the back. I think I need to solder the pins onto here, which I did not do previously, because when this thing started moving, it was just shaking around in there. Like these pins are falling off, or it looks like they are. Anyway, so it's probably not a good connection, so it's probably not really able to read the angle right now, but you know, it's important to not just live in code land. Step out into the real world and tinker around, you know? That's my update for the end of the day. I'm not wearing any pants right now. You probably can't even see. I don't know. Who cares?